We are only page 5 for sections 3.5 and 3.6. Okay, for functions. What are functions? We are going to double define it. Okay, for functions, they have to be functional. That means something has to work. We talk about this in your math 152A class. Okay, so we are going to do the quick review for it. So, what kind of things we call it functional? It has to what? Work, right? Functional means it's working. If it's not working, we don't talk about it in math. So we talk about something are useful. And you need these concepts, okay? Like for the business modeling or pre-calculus, calculus, all the science courses, you need to have these concepts. All right, a little bit abstract for some of you. You don't need this for stats. You don't need the algebra, this class for stats at all. So those are for science concepts. Then let's see. Let's talk about what kind of things are working, what kind of things are not working. Okay, so I'm just going to use, say, Safeway and Rayleigh's, for instance. Okay, so they don't do that, but I just use this as an example. So if we buy turkeys from Safeway, so Safeway says, okay, if 1 to 10 pounds of turkey, I'm going to sell you $10.99. So if above 10 pounds, 10.1 pound to 20 pounds, then I'm going to sell you $15.99. Right? So if you have these 12-pound turkeys and you take to the counter, so how much you have to pay? Then you know you have to pay $15.99, right? Obviously, it's simple. So it works that way. It works, right? One turkey, then how much it is, then you pay for it. And at the Rayleigh's, which is not necessarily the case, but I just use that as an example. So say 1 to 12 pounds, they say, okay, I sell you $11.99, okay? However, they say above 10 pounds to 20 pounds, then they sell you a little bit cheaper. They say $14.99. So when you have a 12-pound turkey, you go to the counter, how much you think you will pay? Okay, they say, okay, I'm going to charge you above 10 pounds, charge you $14.99. But you says, oh, the label says up to 12 pounds is $11.99. Which one you have to pay, right? They can call the manager and ask you, just pay $11.99. But next customer comes, then they have to do it again and again, right? We cannot do business this way. So it's confusing, right? So with the work, we don't think it's working too well, okay? How come? Because this, between here, 12 pounds turkey, right? How much, what's the price? It has 2 prices, so it's confusing, right? So it doesn't work too well. Then how come it's that way. So that's how we look at it. All right, we use xy to express things, right? So for the weight of turkeys, we say it's X pound. Okay, then for the prices, we call it what? Y. So we have from X to Y, right? So it's obvious for the 1X, 12 pounds, then this one, you only have one price, you are okay. But here, you have two prices, you are not okay, right? So, how do we handle it? Then we say, for each X values, right? Then we can only have what? One price, one Y value. So on your paper, how we define the function is, how do we make it work is, for each given X value, we can only have one Y value, right? To make it work. So that's the basic ideas. What kind of things are functional? What kind of things are non-functional? Right? So for all algebra we are learning, it's all about the function. Things have to work to have one result. So we all do the math, same problems, we can only have one answer. It's not say like English or stats, you can have a range of answers and options. We don't do that. We need the precision. Each X value, we can only have what? One Y value. One Y value, okay? So, and the method we are going to use to show the functions are this way. So, in one way, first method is what? Method one is by mapping, which we did. Use the visual effect, okay? So for mapping, it's like 1, 2, 3. Like if I sell nuts, then I say, okay, 1 pound of nuts is $2, 2 pounds is $4, 3 pounds would be $6, right? So that's one way to show. Okay, another one is by this way, like 1, 2, right? 1 to 2, that's your X, that's your Y, right? 2 to 4, then 3 to 6. Then we'll put a curly there, put them together. What kind of things we'll call this? We'll call them ordered pairs, right? By X and Y's. That's how we show. It's the same thing. 1 to 2, 1 to 2, 2 to 4, 3 to 6. Another way to show it is by graphing. You learn this in the 152A class to graph X and Y's. So 1 to 2, 2 to 4, 3 to 6. Things like this by graphing. Order the pairs, still order the pairs, right? Or by the things like formulas, right? And or equations, like your y equals 2x. So we have different methods to show. Okay? Then let's check what kind of things are functions, what kind of things are not. Let's check. okay? To identify them, what kind of things with different methods, and you can tell they are functions or not. So first, let's use the mapping method. So if I say 1, 2, 3, 2, 4, 6, if we do mapping this way, is this a function? Yes or no? What do you think? You might think, oh, it's not. However, it is. If I sell nuts, 1 pound, 2 pounds, 3 pounds, say 1 and 2 pounds of nuts, then I sell it for $2. Can I do that? Just like 1 to 10 pounds of turkeys, it's one price. Okay? Then 3 pounds I sell for $4. Yes, it is a function. What kind of things are not function? If I do this, 1, 2, 3, 2, 4, 6, 8. If some of them 1 pound, you say, okay, $2 or $4. If you put it in the same bucket, if you separate them, that's fine, new one, old one. But if you put them together, then people will ask, how come same 1 pound of nuts, you have 2 prices there? Confusing, right? So 1x, you have 2 y's. So is this a function? No. Okay, so let's see. If we have situation like this, so those are for mapping. So if we do with ordered pairs, how should it look like? Right? Let's take a look. If I write it this way, say, okay, ordered pairs. 1 to 2, 2 to 2, 3 to 4. Is this a function? That's the same thing. 1 to 2, 2 to 2. Oops, is that right? 2 to 2. Oh yeah, 1 to 2, 2 to 2, right? 3 to 4. Is that function? Because each x, you have different y, right? Even same y, but different x. Okay, 1 and 2 pounds can be $2. That's fine. However, if we write 1 to 2 and 1 to 4 and 2 to 6 and 3 to 8, is this a function? Same thing, if you have 2 of the 1s mapped to 2 different y values, okay, so it's not a function. It will not work. Okay, so we are looking at mappings and ordered pairs. How about we look at the graphs, see if they are functions. Okay, so this one is a line. Is this a function? So for each x, you have y. Then another 1x, you only have 1 y maps to it. Okay, mapped to it. So that's your x and y. So this one is a function. Then how about this one? Is this a function? Say here is a 5. So it doesn't matter, you know, how many pounds of turkey, just say $5. Without work? So it is a function. What kind of things are not functional? If you look at this one, okay, so this one, like if you have a 2, here say 2, 3, and 2, -3. So everything on the curves is your x and y's, right? So each one x, you have 2y at this time. So this one is not a function. So how do we check? Okay, we use things called vertical line test. When your paper run, okay, on your left, on the top, we call it what? Vertical line test. If your vertical line intersects the curve with 2 points, then it's not a function. Okay, so we use vertical line test. If we have this one, like this, is this a function? Vertical line test. Okay, if we have this one, is this a function? No. Right? So, if we have this one, parabola, is this a function? Yes. Okay, this sideways parabola, it's not. So, if you have this one, is this a function? No. Right? So 1x value says 3, 0, 3, 1, 3, 2, right? So if you have this one, like here, if that's same value here, you use a vertical line test. So this one is not a function. Okay? So we show you different methods to use for the functions. Then we identify them if they are functions or not by mapping, ordered pairs, graphing, or we can use formula equations. Okay, so let's take a look. Different one. Y equals mx plus b. Remember that? So first one is you both have x and y's. So that's a slant line, right? So like those. You can use what? We have 3 ways to graph it. We can use what? 3 points t-table, or use t-tables with 2 points, special 2 points, intersects, right? Also, we can use what? Y equals mx plus b, rise over run, right? So if we graph with t-table, x, y, 0, 0, 1, 1, 2, 2, right? Like this. So when we graph it, so that will look like 1, 1, 2, 2, like this. So you usually cannot really tell with the equation whether or not they are functions. You have to see it, visualize it. So you use vertical line test. Is this a function? Yes. Right? Then for this one, we graph it. So we use y equals mx plus b to graph it. How do we do it? So this one is what? Slope is 2 and y-intercept is 1. Y-intercept is 0, 1, right? Then slope is what? 2. 2 over 1. Rise over run. So you rise 2 steps, run over 1, right? Rise 2 steps, 1, run over 1. So that point would be 1, 3. That point would be 2, 5, right? So you graph it. Is this a function? Vertical line test. Right? For those two equations, you don't have x or you don't have y, not both. And let's see, that would be special case, okay? That would be this one, y equals 5 means what? Y is 5. 1, 2, 3, 4, 5. Then you don't have x. X can run free, can be any numbers, right? Then x is running left and right. So your line will look like this. So is this a function? Yes. Okay? Special cases, it's not slant line because you don't have both x and y's. Then you just have a y, it will look like this. Okay? What happens if you, let me double check my equation. Yes. Okay. So if I have x equals -1, how do they look like? X -1 is this. X -1. And you don't have a y. Y is running free, and y is what? Going up and down. So that's a special line, vertical line. Okay? So, is this a function? Vertical line test. It's not a function. Okay? So we have 4 different ways to describe the function. Right? And let's talk about it formally. So if I ask you, what is a function? How would you describe it? We have 4 methods, but we use a second method. Okay, second method. A function is what? A set of ordered pairs. We use that, right? But not any ordered pairs will work as functions, right? So we have to have what? Each x value, we can only have what? 1 y value. So exactly 1 y value. Okay, so if I ask you what are functions, how would you describe? You would say a function is a set of ordered pairs which for each x you can only have exactly 1 y values. Okay, that's on your page 6. So functions are talking about those things, x and y's, right? That means how do you get from x to y? From point A to point B. How do you get from A to B? How do you get from x to y? So function is talking about from point A to point B, point X to point Y. So how do we relate our result from where we started? Okay, so functions, a set of ordered pairs, is always talking about from point A to point B. It's talking about how do we relate things. It's talking about relation. So algebra is all about functions. Then it's all about relations. How do we relate things? How do we relate our understanding? That's how we are trained in algebra to relate our thinking. How do we get from point A to point B. How do we learn? That's how we learn algebra, okay? Then for the things from beginning point A, we call it domain. To where we going, we call it range, okay? So domain is what? All about all the x values, okay? Range is about all the y values. So domain means what? Your territory, right? Domain, the territory. So where you are working from, then if I sell nuts, nuts are my territory, right? If I sell turkeys, then I'm dealing with the territory of turkeys. Then range would be my price range, right? So for the things where we started, then point A we call domain. To get where we are going, point B is the range. That's how we work with the functions, okay? With domain and range. So if I ask you, if I have these ordered pairs, is this a function? Okay. So if my trail mix $1 to £1 to $5, 2 pounds to $10, 3 pounds to $15, yes, they are function. It is a function. So what's my domain? My domain would be what? 1 pound, 2 pounds, 3 pounds, right? 1, 2, 3. That's my domain, the territories I'm working with. Then I put a curly around it. Okay, what's my range? Would be 5, 10, and 15. Oh, we don't use that. We use what? Curly, a set, to a basket to put the things into a domain and range. So it's like your T-table, 1, 2, 3, 5, 10, 15. Then X is your domain, Y is your range. Okay? Then let's identify, we talk about functions. Then have to be functional and have 4 ways to describe it, right? Then formal definition is what? They are ordered pairs, then each x only have what? Each x only has exactly one y value, right? How do we relate from x to y? Then that's function talking about. Okay, so in the meantime, all the x's we call it domain. All the y's we call it what? The range. Now let's identify our domain and range, okay, from the graphs. So look at your next paper, page 7. All right, so let's see, for those graphs, then if I have this one to here, from -3 to -2, -3, -2 to 5 and 4. What's my domain? What's my range? Domain is what? All x values. So x run left to right. Range for y's run up and down, right? So how far you can go left, how far you can go right for the points on the graphs, right? So start from -3 to 5. So -3 to 5. We use interval notations. You use bracket, okay? Means inclusive, including the endpoints. Okay, from -3 to 5. It can go left and right. Okay, how can it go up and down from where? -2 to 4. So that would be -2 to 4. That's how we show domain and range. Okay, so if we have this one, this is the line go up all the way. So how far you can go left, how far you can go right. Okay, so your domain is what? All the way, all the way. So it's what? -infinity to infinity. For interval notations, you always write from smaller number to the larger number, right? So you always write from smaller number to a larger number, okay? Then sometimes you use bracket if it includes the endpoints, right? Then if you go forever, we use infinity sign. For infinity, you always use parentheses. Or you can use this one, Roman symbol, R with double stripe, right? What's your range? How far you can go up and down? Okay, same thing. If you have line like this, instead of going up from left to right, if you go down from left to right. So what's your domain? Same thing, all the way left and all the way right. What's your range? Same thing, all the way up and all the way down, right? What happens if we have this one? If I have 4, -4 and -1 from here, then we go up, okay? Then 5 to 5, -2. 5 to 5, 2. Okay. If here. So what's your domain? How far you can go left and right. From left to right. So it's a -4 to 2 with bracket. Right? Then what's your range? How far you can go up and down is up to from -1 to 2. So you write it from smaller number to a larger number for your interval notation. Okay? So number 5, if you have this one, then here is 3, 2, okay? Goes forever, goes forever. So what's your domain? Left and right. All real numbers. Right? What's your range? How far you can go up, how far you can go down. Go down forever, go up, you stop right here. Right here, which is y, right? 2. So that would be what? -infinity to 2. Right? Okay, so that's number 5. How about 6? So if you have this way, if it's a -3, -3 and -4, okay, so you go up here, go up here. So what's your domain? What's your range? Left and right, how far you can go, right? All real numbers. So what's your range? How far you can go down, how far you can go up. Going down, you stop with what? -4. So -4. All the way up, so you go to infinity. Right? How about parabola? You are going to learn this in this class. Okay, So 2, 0. So what's your domain? Left and right, all real numbers, right? And I think for computers, and you don't have this symbol, you have to choose this symbol. Use the interval notations. So how about your range? Range will be what? Up and down, right? So going from here all the way up. Here is not 2, it's 0, it's y. From 0 up. So you're from 0 to infinity. Right? So next one, what happens if you have upside down parabola? Right? -1 and 4. What's your domain? Left and right. Okay, forever going. So it's all real numbers. How about range? Up and down. Cannot go up after that, up to 4, all the way down to negative infinity, right? So you do negative infinity to where? 4. Right? How about number 9? If you have a situation like this, so your test is more like this: -4 and 3 to -1, -4 and 3 down to -1, -1, right? Then you go up to 4, 5. So that's your 4. Okay, 4, 5. And you come down again to 6, 2. 6, -2. Okay, so what's your domain? Left and right, how far you can go. From here, -4 to where? 6, right? So that would be -4 to 6. How about your range? How far you can go up and down? Lowest would be -2. Highest would be what? 5. Then you write what? From smaller number to a larger number. Okay? So that would be -2 to 5 with brackets. Right? So let's take a look at next one. So number 10, if you have this, right? Is this a function? Vertical line test, yes. So what's your domain? Left and right, right? So it's all real numbers. What's your range? How far you can go up and down? It doesn't go up, it doesn't go down. It's all at this point, which is 2. So you only have 1 point, not a range of point. Range of points, you use interval notation. So only 1 point, just 2. Then you put it into the basket, a set. Use that symbol to do that. Okay, so we are identifying what? Domain and range for the functions, right? And let's see, next one is this one. Is this a function? No, not a function. So when it is not a function, we don't talk about domain or range. Okay, domains and ranges are for the functions. Good? So we identify them first, all right, from the graphs. Then sometimes that would be easier because you can see it. However, if we have a situation like this, we use the equations. You can use calculators to graph it, then you can tell. Okay, we are going to learn how to graph it in this class. So, but for the moment, they are special kinds because what? That's the radicals, right? Like a radical 2, radical 3, you learn in your 152b class. Then if you have this one, it's a fraction. In your 152b class, what do we call this? This one would be radical function. This one would be what? Rational, right? Ratio. And with polynomials, then we call them rational functions. And for the fractions, we have restrictions. For the radicals, we have restrictions. Okay? Then this one would be regular polynomials. So we say for radicals, it can be square root of 2, 3. Can I be square root of 0? Which is 0, yes. Square root of 1 is 1. Can I do square root of negative 1 or square root of negative 2? We say they don't exist, right? Because anything take a square cannot be negative number. So that means what? Inside the radicals, even radicals, right? Cannot be what? Negative numbers. That means x plus 1 has to be what? At least 0. That means x plus 1 at least be 0 or above 0, right? That means what? Your minus 1, right? Things like that. X has to be what? Bigger than or equal to, oops, not 0, negative 1, right? So formally we do this way. How do we show what's your x? You do x, you put a bar there and show the restrictions behind the bar, right? X bigger than negative. Then with curly bracket to put them together. Okay? So for radical things, you need to have a restriction. We say 2 things we have learned so far. Then you have restrictions. One is radicals, even radicals, right? Another one is fraction. You can put x. If you try to graph it, you use the t-bar, right? T-chart. Put the x there, then find your y. But it's a fraction. What kind of restrictions you have? The denominator cannot be 0. So x can be any real number. You can say x, right? All real numbers except what? Make a denominator 0, which is 5. Okay? So you can do it that way, or you can show it which way. All right, interval notations means what? Everything except the 5. You can use negative infinity to 5, put the parentheses there, and 5 to infinity. Then you use union in between. You can show it this way. Right? Or formally you can show it. This is x. Then you say x are all real numbers except 5. Okay, you can do that. How about next one? 3x minus 7. If you do the graphs by y equals mx plus b, right? That's your negative 7. Then you rise over run, 3 over 1, right? Rise over run. So your line looks like this. So what's your domain? Domain will be what? All real numbers. Right? So we identify our domains and range with what? The graphs. right? Or from the equations, you cannot see the range. You have to use calculator. It's easier that way for you, okay? So then for the domains, you can identify them, okay? So we are talking about functions, things that work, right? And different methods to show them for the ordered pairs, right? For each x, you only have what? One y value. Then we identify domains and ranges with what? For the equations as well. Okay, so one more thing. For functions, we need you to know the notation, the symbols. You know, a lot of time, half of the battles, like in calculus, you have to deal with the symbols, notations, how we use to identify things. Okay? Just like the red colors, anything can be red, but if the lights, red lights, it's red colors, but it means something. It means you have to stop, right? So symbols connect with the meanings. And so you need to know the symbols, okay, for math, especially. So if I have y equals 3x minus 1, and y, that's a first degree polynomials, right? And y equals x squared to 2x, second degree poly, right? If we have a situation like this, then we said, okay, if my x is 2, what is y? Then you are not sure which one you are going to use, right? Because I didn't identify them for you. So we need to differentiate that. Both are functions. You know this one is a function. You don't know this one is a function yet. You are going to learn that later. So we are going to identify them. They are functions, right? So I say this is a f, a function. And I follow alphabetical order to differentiate them. I say this is a g. At the same time, because y is getting from x to y, so I say this is f of x, this is g of x. So when we talk about f of x, g of x, it means y. All right, so we use those symbols, okay, f and g. So if I ask you, find the f of 2, what does that mean? Inside of the parentheses of f, that means it's your x. From x is 2, you get to y, what is your y? So which one we need to plug in? Right? First one. So you plug in 2 times 3 minus 1, it's 5. That's what it means. So this symbol means what? Find your y when x is 2. That is, x is 2, what's your y? Then if we ask you g of 2, what does that mean? When x is 2, what's your y from the function of g, right? From this one. So you need to do 2 squared minus 2 times 2 equals what? 0. The result is 0. Okay? And sometimes we look at this way. All right. We want you to identify the y from the graphs. Okay? So the first one, you have things like this. Then I give you a curve. upside down parabola, I say this one called f of x. F of x means what? It's your y. So each point on the line is your x and y, from x to y, right? X is here, y is here. Okay, so if we give you this, the graph, we call this one is f. Okay, so we ask you what is f negative 4. What do we need you to do? It means find your y. It means what? Find the y when x is negative 4. It's here. So we identify them. So this point, order the pairs, f, right? Function is order the pairs. So this one is -1, -2, -1. This one is -1, -2. So you just see your x, y axis. So that's -2, -3, -2. Here is -4, -5. So what is f -4 mean? It's a symbol. Means the function for function f, this guy, and when x is -4, what's your y? From -4, where can you get to from this, follow this path? You get to y is what? -5. Right? And write your answer as order the pairs. So you write this one, -4, -5. Is that right? Okay, let's look the next one. You have g of x. Okay, so it goes like here and like here. Okay, so then on the lines, on the curve, each point is your x and y, right? X is whatever x is. Y is, we call it g of x, right? So he asks you find the g of 2. That means, what does that mean? What does this symbol mean? So it means when x is 2, what is y? So x is 2 is here. Then what's your y? Y is 0. So that would be what? That would be 0. Write it in the order of pairs. So you will be 2, 0. Okay? Write your answer in an ordered pair. So that's how we handle the function. That would be your sections 3.5 and 3.6. This is one of the miscellaneous things we are learning and we need to use throughout the course. Okay?